All right, so this is the end of the semester. It's the last week of classes, finals coming up, and it's the last day of the Secure Coding Pirate class that I appreciate you people helping me with. For this beta test, I'll be teaching it to a bunch of college teachers over the summer. And so we're going to talk about security testing today, and we're going to talk about OWASP ZAP, because a student said the OWASP ZAP scan does not detect SQL injection. And that is true, and I found out what the problem is and how to fix it, and I'll demonstrate that. So, first we'll talk about security testing, which is pretty simple, although very interesting to me to understand what people should be doing, and it's sort of shocking how much they're not doing it. So security testing, we'll have various examples of this and talk about it. And I must say the one thing I learned here from my experience reporting vulnerabilities is it's clear that people aren't even doing regression testing properly. So that's why this class is needed. So we're going to talk about, all right, so security testing here. Most testing is functionality testing. They write some code, then they test to make sure it works, which means under normal conditions, when people are using it as intended, it does what it's supposed to do. And this, by the way, was Microsoft's official position. Bill Gates explained this. Until 2002, Bill Gates said, it is a waste of time to try to make products secure against malicious inputs. There aren't that many hackers. It's not that big a problem. What we really need is code that works as intended for people that are honestly trying to get their work done. So just make things work for normal users under normal conditions and ship it. And that's all we really need to do. Security is not really a problem. And they held that position until 2002, when Bill Gates put out the Secure Computing memo saying, all right, I've changed my mind about this. The amount of viruses on Windows XP and everything have gotten out of hand to where this is crazy. So now we're going to have to put security as a higher priority. And then last week, because Microsoft has had huge security scandals caused by their failure to secure the cloud, so a bunch of government cloud email servers got hacked into, a bunch of government email accounts got hacked into, embarrassing Microsoft greatly, and their response made it extremely clear that their security controls are very lacking, and they just ridiculous things happen, and they don't even know how the Russians got in, or Chinese, or whoever it was. They had another memo like this from the CEO of Microsoft last week, saying, we are going to focus on security, make security first. We're even going to accept delaying or not offering new features, make everything secure first. A big push to improve their security again, because just as in 2002, the security problems have gotten so large it's endangering the business. So we'll see what comes of it. But anyway, this is the kind of thing that should happen. You should have tests, not just functionality tests, to make sure that the code works correctly under normal conditions, but you should have security tests, which means that things that should be forbidden are in fact blocked. So here's types like integer overflows. When a number gets too big, it'll roll over and become small again. Memory management problems like buffer overflows, untrusted inputs, web security like cross-site scripting, and so on, and flaws in handling exceptions. These are all common security problems, and you can have test cases to see if these things are handled correctly. So, for example, the go-to-fail, they gave you the whole function in the book. I think this is unnecessary detail. I think this is the part that matters. You're doing several tests on a security certificate. You're testing if you can hash something, and if it doesn't work, then you go to fail. Then you have another hash, you test something, and you go to fail. Then you have an extra go to fail line here, which causes the problem. So steps 3 and 4 never happen. Regardless of whether this test is true or false, it jumps down to fail and returns an error. And so this was the point. This last test was the one that actually checked if the security certificate was valid. The others were just calculating some hash values you were going to need for that final test. So it never actually gets to the important step. It skips it entirely. And the problem here is functional testing will pass. They test it to see, under normal conditions, with a valid certificate, does it work? And it works. They did not test, does it reject an invalid certificate, which would be the more important thing to test here. I should be more careful. The most important thing, of course, is that it works under normal circumstances. If it doesn't do that, then normal users can't use it. It's totally broken. It's useless. Therefore, software developers are correct to say the most important thing is to make sure it works. Now, to make sure it fails, under certain error conditions seems kind of like a waste of time, like Microsoft used to say, and that's what they're failing to do, of course. But that's what you need to do for security boundaries, to make sure that the insecure thing is in fact blocked. So you'd try various invalid certificates and other problems like date problems and such, and make sure that they're all rejected. So you should have security tests, especially for security critical code, and you'll have to check to make sure that things are denied. Access is denied, input is denied, or otherwise the test fails. Otherwise, your security controls are not actually blocking bad things that you want them to block. So write your security test cases. And the best thing is to create them along with your unit tests. And this is why you need to get through to the real developers, which is why I'm teaching this course. Instead of having software written and then have, after it's done, a security audit, you need the developers, when planning the software, writing it in the first place, to be thinking about both the functionality and the cases that should be blocked, and making sure both of those are getting blocked. Let's see a question here. Does Microsoft still have a testing department for their Office products in this cloud age? Yes, it's a very good question. And I don't have any inside information from Microsoft, but just from using their products, it seems to me like they do not seem to have effective regression testing. And that's the main point here. Obviously, they don't have enough test cases. They don't apply them rigorously, and they should, because flaws keep slipping through. And in particular, old flaws keep coming back. And that should be easily prevented. And that's the whole point of this chapter, is it's not that difficult. There is a way to test your product so you don't bring old flaws back, at least to lower the chance of that. So that's the point. So when you're writing code, you should think, I want this code to do this good thing. And you should also say, oh, if the number is too big, I want it rejected. If the string is too long, I want it rejected. And you should write a test while you're developing the code that says, so we'll test it by feeding in a normal thing and make sure it goes through, and then we'll feed a thing that's too big and make sure it's blocked, that sort of thing. So you should, so for example, if the input field should be alphanumeric 10 to 20 characters, then you'll check that a input of length 10 works but 9 fails because it's too short, and make sure that 20 works but 21 fails because it's too long. And check that if it has invalid characters that are not letters or numbers, it fails. These are just automated tests you should have. All right. So cross-site scripting we did before. The user submits a color parameter that's applied to some text, and therefore this code includes data from the user in a line of output, and therefore if the user puts in a parameter with a quotation mark and sees angle brackets, less than and greater than signs in the correct pattern, they can inject code. So that's cross-site scripting. So to test for this, if your output contains user-controlled values, then you try putting in special characters here and see if they break the syntax. Here's a pretty good way to do it. There's a function here that will feed in an X and an X with a double quote, and then it's going to use the beautiful soup parser. It's going to add a tag to the end of the page called a meta tag with just arbitrary content, and then it's going to parse it with beautiful soup and see if that tag is still there and intact. Because if that created a mismatched quote somewhere, then it would have presumably broken the structure of the page and damaged this tag. I'm not sure that's a perfect test, but it's a pretty clever test. And by the way, you could expand it to fuzz testing, where instead of just trying a double quote, you try a whole bunch of things, like all possible punctuation marks, and try them one by one in doing this test to see if any punctuation marks will break the pattern of code, and that's a very good plan. Almost a whole lot of vulnerabilities rely on injecting special characters, so testing for them all and making sure that none of them are misunderstood is a good plan. All right. And so then there's regression tests, which is what I mentioned before. A regression test is the test to make sure you, after every update, that you haven't broken something. And this is what seems to be failing at Microsoft and other companies too, to be fair. They update something and now they bring an old problem back. So if you had proper regression testing, you would just have an automated series of tests after every update to make sure that the problems we know about are still passing. And apparently they don't have that effectively. So that's the plan here. And so you could create a security regression test for that, where you test to make sure that a security problem is gone, like, the length up to a certain length is accepted and above that it's rejected, and you just make that an automated process after every update. Make sure that the boundaries that are supposed to be there are still there. So now this is something I've seen a lot of times. Somebody writes a vulnerability report, reporting something like this SQL injection vulnerability here, where they put in this name Robert apostrophe parentheses semicolon etc., and that creates a problem. And the engineers at the company that don't understand security very well, they just block that exact attack. Don't accept Robert apostrophe semicolon parentheses. They don't understand that there's a whole class of attacks like that, and you have to block them all. They just block that one specific attack, and then they say they're done. So when you're test to make sure you fix this, you should try other things, double quote instead of single quote, backslashes, and other things like that. The kind of things. This is why it's extremely common that you report a vulnerability, they tell you it's fixed, you test it, and all you have to do is make a minor modification in the attack and it still goes through. Heartbleed, for example. Heartbleed was the huge problem with HTTPS servers we talked about before, where you can make a request telling it you're sending it 16,000 bytes, but only send it a few bytes, and it will reply with 16,000 bytes without noticing that it didn't actually get that many from you, so you get large amounts of uninitialized memory, which can contain secrets. So if you want to prevent this, and you want to do regression testing to make sure it hasn't come back, then you test that the known exploit requests no longer receive a response to make sure your server is patched. Then check that if the count is greater than the maximum, it's rejected, payloads of 0 byte and maximum byte size, and so on. Make a series of test cases and make this part of your automated test against your web server to make sure your web server no longer has this vulnerability. All right, and then there's availability testing. If you consider denial of service attacks, like the ones we talked about, you can write a regular expression test where certain kinds of input will just take forever and freeze up the server. So you use security test cases to determine a limit on the rate of input. So try making things bigger and more complicated until they burden the server too much. Figure out how much you can handle, and then put input validation. So if you have some complicated regular expression that doubles its processing time every time you add another letter, and you can't think of a way to avoid that, then just say, well, I will limit that input to only 10 or 15 characters, because after that the resource consumption gets too large. That's the idea. Find out what service you can provide and put in a limit to prevent a request that would demand more service than that. And you can also test your system by lowering the amount of memory available to make your server weaker, if you want, to make it easier to find the limit. And then you have threshold testing. It'd be nice to give them warning signs before limits are reached. This is something that just came out last week again from CISA. The U.S. government CISA set a list of recommended practices in developing software, and one of them that really caught my attention was where they said when you design products, you should make it easy for the user to notice when that product has been attacked or hacked. That would be awesome. No products have that right now, like some kind of red light that goes on saying, hey, your product is under attack, your product has been hacked. So, and here you should have warning signs for the things you can understand, like when you have an integer overflow, when something is too big, when storage capacity is filling, when certificates are expiring, things like that. It would be nice to pop up alerts to the users telling them this bad thing is happening, so rather than the program just crashing and then you wonder why, you get a useful warning message to guide you. The Y2K bug is one that caught a lot of people by surprise. When 1999 turned into 2000, old COBOL-based software had only stored the year as a 2-digit integer, so it interpreted that as going back to 1900. And we're getting pretty close to the Y2K38 bug, which is coming. All Unix and Linux systems work. They keep track of time by having a single integer, which I think is 32 bits, but it goes up to 16,000. I guess it's 24 bits. It counts the number of seconds since January 1, 1970, and that is going to hit its maximum and roll over in 2038. So that's only 14 years away. So products being designed now using standard Linux may well still be in use at that time, and they may have a security problem then, or a functionality problem. And then, of course, distributed denial of service attacks are where many computers all attack you at once from many locations, and you typically can't patch that in your server software. That's really a matter for your load balancers, firewalls, and ISPs. You can't realistically plan to handle that at one server. So here's the best practices. Write tests concurrently with new code. It really would make sense to write your tests first. The Y2K, thing about the 2038 bug. I've heard about it for many years. We really should update Linux to use like a longer count for that number of seconds or something, but nobody's done it yet. And it's coming 14 years away. Anyway, so logically, when you're writing code to do something, you should think, well, I want it to do this, therefore it should reject this input and that input, and you should just design it when you're first designing the code. What is the test to make sure this code works? You have to test your code anyway. And integration testing is something you do. You test each component, each little function individually till it works. Then you put it together, and then you test the whole system, because often new problems appear when you connect the pieces together. Do things like log in and make sure the password doesn't appear in logs or any other public place. This is something that would catch. This is what horrified me when I started doing Android apps. It's painfully obvious that nobody has done any security testing at all. It just puts the password in the log. One of them, I report one vulnerability and they add that vulnerability to it. Now there's 2 copies of the password in the log. Obviously, they're not doing any simple tests to just make sure that like the top 10 bad things aren't happening, like the OWASP top 10. And then if you have, as everybody does, a problem of legacy code, they call this technical debt. You have a bunch of code that was written earlier before anybody thought about security. And now what do? And so this is catch up. So you go through your code base, old code base that didn't have any security tests, figure out to divide the job into pieces, starting with high priority things, which are the protection mechanisms like logins and security barriers, and functional areas that are important, and try to devise test cases for them. And this, I think, is the main job that's coming in the world. Even if people start adopting better coding practices, they're going to have to somehow deal with their technical debt of all the old code that was written sloppily. Anyway, let's take a look at a Kahoot. All right, and here it is. And I should have somewhere to record the winners, and I do. I expected to see at least you 2 folks here. Good. All right. All right, so what test makes sure that your old bugs don't reappear? That's a regression test. Make sure you're not slipping back to an inferior position. Right, what test sends a long list of altered inputs? That's fuzz testing. You send a whole lot of random things or things drawn from a long list of test cases. And what test detects denial of service vulnerabilities? That's availability. All right. And there's only 2 of you, so I know who won.